All right, let's take a look at solving equations and solving inequalities. What you should notice about these two equations is that they both have x's and y's on the same side. So if you have x's and y's on the same side, you're going to be using the elimination strategy. Essentially what you're going to be trying to do is you're going to be trying to figure out a way that you can make numbers that are stacked on top of each other that are opposites so that when you add them going down, they quote unquote eliminate. So a choice that you would have in this problem is that you could multiply this top equation by 2, because then you would essentially take 2 times each of these and you would have 4x plus 2y equals 6. And then when you added this part right here going down, those would eliminate and you would have negative 2y equals negative 2, and you can solve y from there, get the y value, plug it back in either here or here, and solve for x. Looking at the second example, I would probably pick these two because those are multiples of each other, meaning if I multiplied the top equation by 3, then I would have a positive 6 sitting over a negative 6. I feel like that's probably the smartest way to go. And as you can see, the hint for this setup is elimination, because in the elimination strategy, you can then, like I showed you, eliminate one of the variables and solve for the other one. The answers are here. Hopefully you've worked them out on your paper already. If not, this is an opportunity for you to do that and then check to get these two answers here of the 1, 1 and the 2, 10. Remember, x comes first, y comes second, and we show our answer as an ordered pair. In an equation or situation where we have a system of inequalities now, we don't have equations, we have less than and we have greater than symbols. And then this to me looks like it's going to be a parabola. This is going to be a line. And then I'm noticing that this is telling me, because it's just plain less than, it's going to be a dashed parabola. And this is going to be a dashed line. Now this is greater than, so then it's going to be shaded above. This is less than, so it's going to be shaded below. So if we were to take a look at this, we can use our calculators, so you can graph these on your calculator and set it to shade above with the greater than symbol or below with the less than symbol. So you get in your y equals and your arrow over to here and you keep pushing enter until this shows up. This would represent less than because it's this kind of a shape and it's shaded below the line. So when you look over here, the shading is below this line. The way you test that is you pick 1 point vertically down here and 1 point straight above it. And then obviously if I had a point up here and a point down here, then this would be less than the point that was up here. So you know to shade on this side. So you just move your cursor to the far left and keep hitting enter. That's how you do it. You keep hitting enter until it changes this symbol. And that of course would be the less than. All right, and then if you actually put these into your calculator, this is basically what you're going to end up with. The thing to note, though, is obviously I told you already, this is a dashed parabola. This is a dashed line, and it was supposed to be greater than the line. That's why it's shaded above it. It was supposed to be less than the parabola. That's why it's shaded down below it. The actual answer is this double coloring shape right here. This upside down kind of bowl-looking shape is actually the answer. So notice, though, that these are both dashed. They're not solid because it was just less than or greater than. If it was equal to, then we would have to then use the solid lines. All right, another equation we're supposed to be able to solve is absolute values. Now these two are pretty simple examples because they already have the absolute value bars alone. If you had an extra number like right in here somewhere that said like, plus 2 or something, you'd have to minus that 2 off. Then once you get the absolute value bars alone, basically the process that we've been doing is splitting this into 2 equations. So you'd have like x plus 3 equals 5, and you'd have x plus 3 equals negative 5, and that would be your 2 equations that you're solving to get your 2 answers. This is what you change. You do not mess with anything in here. This stays what it is. You just split that into 2, equaling the positive version of this answer, and then the negative version of this answer is how you work through it. So the hint is isolate the absolute value bars. Well, they're already isolated. They're already by themselves. Okay, then you split it into 2, being the positive and the negative version of that answer. Hopefully you've worked these out. If not, here are the 2 answers you should be getting. You'll notice that this is not listed as a coordinate. It's x equals because there's only x in the question. And we do typically list them from least to greatest. So the two answers would be x equals -8 and +2. And you could plug those back in and you could see that if I put 2 in here, 2 plus 3 is 5. That obviously is the absolute value of 5. If I put the -8 in, that makes -5. The absolute value of -5, of course, is 5. Worth looking at, knowing how to solve absolute value equations. All right, then the next one is show the solution using inequalities in a number line. So what you should notice here is you have absolute value, which means we're going to have two solutions, and we have greater than or equal to. So that means we're going to color in and make a solid dot at that point. But we have to remember how to solve this absolute value. Well, we just practiced that. So this is one of those where you will split it into two. So you'll take it and go 2x minus 4 equals 16. And then over here, you'll do 2x minus 4 equals -16. And you'll solve both of those equations. Then once you solve both those equations, then you can get your two boundary points, as we call them. So the hint is isolate the absolute value bars. It's already done that way. Then split it into two equations, which I just showed you. One is going to equal the positive, one's going to equal the negative. Find the two solutions and mark them on the number line. Then this is the key. Then test 0. If 0 works in the equation, then shade in that direction. If 0 doesn't work, then don't shade where 0 is. So when I go ahead and solve these, those two equations that I had on here, I'm going to mark the points as -6 and 10, which I've done here, and I'm going to test 0. So I'm going to take 0 and I'm going to plug it into the equation. Well, 2 times 0 is 0. Then it basically yields this. It's the absolute value of -4. Is that greater than or equal to 16? No, because that's 4 is greater than or equal to 16, which is not true. So I should not shade where this 0 is. Your only choices are shading between the 2 points or shading on the outsides of those 2 points. So you'll notice there is no shading here. We are closed circle because it was greater than or equal to up here in the problem. So I close this circle in and I shade away from 0. Now you'll notice this is a split graph. And when we have a split graph, that's when you use the word or, because we're either this direction or this direction, and we need to put that word in between, and then these symbols match which way you're shading. What if we flipped this over to less than or equal to? So that's a slight change. All that it does is we still end up knowing it's going to be -6 and 10 because we already did this question. But then when we test 0, 0 would actually have worked because then we would have had 4 is less than or equal to 16, which would have been true. So that means the 0 was here and we should have colored here. I'm showing you this because this is called an AND inequality or an AND graph. And so when we do an AND, we have the two endpoints colored in because it was less than or equal to, but we're colored in here. And then the way we write it is like this. Because then it's -6 is less than or equal to x, which is less than or equal to 10. You're basically saying -6 is less than 10, which is, less than or equal to 10, which is keeping it true. That's why these are always have to be less than signs or less than or equal to signs when you put those in between here. It's like the way we did domain and range notation at the beginning of the school year. All right, how do you solve for x when the equations get a little bit more complex? Again, this is just reverse order of operations. You literally just add 8 over here, divide by 5, then take a square root. But when you take a square root, you have to remember that that's telling you you're going to have two solutions. So you have to watch out for the plus and minus at that point. Down here, I would subtract 5. And then now you've got 3 to a power. So you've got exponential base 3. So you have two choices. You could do log base 3 on both sides, or you could try to figure out what power of 3 would make then 81. So there is ways to solve those equations. Again, my big hint on this is just reverse order of operations and solve for x. Here are the answers. You should be able to figure them out. That's why I'm putting them on here. So if you haven't solved these yet, you can use the answers to check your work. Then in this example, solving an inequality where you have more complicated sides. So if we have an x squared and an x on one side or whatever, and then we have an x on this side, essentially you've got to remember that if you ever have an x squared and an x in the same problem, x squared and an x, then you have to make sure that you move everything over to one side, and then you can use quadratic formula. So quadratic formula is great when you have an x and an x squared in a problem because you can find those two solutions pretty quickly using quad form. So if I moved everything over and I used quad form, that gave me the boundary points of -2 and 4. 0 would live right here. Then if I plug 0 into this equation, that makes 0, this makes 0. So I get -6 is less than or equal to 2, which is true. So I'm going to shade where 0 is. So I'm going to color in here. And remember, these are colored in because that was equal to. If that was just plain less than, then these would be open. Okay, so then it is -2 is less than or equal to x is less than or equal to 4. Those are all the ways of solving equations and inequalities that you need to know for this unit.